Hey kids, Charlie Busso here. We're going to do homework number 2 for bonding. We have to give examples of compounds that make bonds like this and then write their formulas. Single polar covalent bond, almost guaranteed example is going to be HCl. 2 atoms, there's a difference in electronegativity. Hydrogen's 2.2, chlorine's 3.2, that makes it a 1.0 difference. That makes it polar. Hydrogen has 1 dot. Chlorine has 7. They share a single bond. Another single polar covalent bond would be H2O. Now, actually, when this bonds, there's going to be 2 bonds. Both are going to be single polar covalent. The single nonpolar covalent, we're going to go with H2. It's going to look like this, H and another H, and they share a single pair of electrons. Another single nonpolar covalent bond might be F2. Fluorine has 7 dots, and the other one right next to it is also going to have 7 dots, and they're going to share 1 pair of electrons. Double polar covalent bond automatically is carbon dioxide, and another double polar covalent bond might be silicon dioxide, which is beach sand, all right? I'll remind you, that's what you put your toes in at the beach. A double nonpolar covalent bond might be CS2, not CSI, that's a TV show, carbon disulfide. And another double nonpolar covalent bond might be C2H6, which is going to look like this. Carbon is going to make a single bond in the middle, and then we're going to have H's all around. Up, that's a single bond, my mistake. I'm going to squeeze in here C2H4, right? Because we want to have a double bond. So carbon is going to bond this way with 4 hydrogens, and in there is a double nonpolar covalent bond. Okay? The one I drew is a single, right? Boom, oops. Triple polar covalent bond. Triple polar, the only one I can think of would be HCN, which is going to look like this. H bonds to carbon, which bonds to nitrogen. Now, a triple nonpolar covalent bond might be C2H2. We would have the hydrogen bond to a carbon, and then carbon would triple bond to another carbon that bonds to a single hydrogen. It's a triple nonpolar covalent bond in the middle. Coordination number. This is the number of opposite charged ions, opposite charged ions surrounding any ion in an ionic solid. This helps determine the actual shape of the crystal. When the positive and negative ions bond together, they're going to fit together in a certain pattern. And that's just going to grow and grow and grow. And depends on how many of the positive ions fit around each negative anion, or reverse, how many negative anions fit around every positive cation. That structural shape is going to grow by the billions of ions until the crystal gets the right shape. An alloy is a mixture of usually 2 or more metals, and I'm going to say sometimes a nonmetal, sometimes metal and nonmetal, that has different strengths and qualities. For instance, brass. Brass is made of 2 metals that are melted together, and structurally, the zinc and the copper are better together. They're more durable and more strong, so your trombone, when you drop it, doesn't dent. It's much more structurally conducive to being a brass instrument. A strong, solid, won't rust, won't tarnish. It's a pretty good combination, but it's a mixture. You can separate them by melting them. By taking advantage of the difference in melting points, you can get the metals back separate again. Electronegativity is the tendency to get, and I'm going to put that in quotation marks, to get electrons in a bond. When two atoms bond together, they're going to share their electrons, and one atom is going to pull as hard as they can to get those electrons, and so is the other atom. That tendency to pull the electrons to get that full outer orbital, that's called electronegativity. And every atom has an electronegativity value that's on table S, outlined by Linus Pauling. Now, I'm going to move this aside so I can draw on some white paper. And we have to draw the Lewis dot diagrams for, I think it's a dozen of these. Diatomic fluorine. Fluorine has 7 valence electrons. There they are. Another fluorine right next to it is going to have 2, 4, 6, 7 valence electrons. So that's F2. Diatomic nitrogen. Nitrogen has 5 valence electrons. Now, this is one you're going to have to just remember. We're going to have to put the electrons that way so that I can put another nitrogen with 3 electrons and then 2 on the outside. This is going to make a triple nonpolar covalent bond. Diatomic hydrogen is going to look like this. Hydrogen has 1 dot or 1 electron each. They each share 1 electron with each other. Diatomic oxygen. Oxygen is going to have 6 valence electrons in pairs, and then the other oxygen right next to it is going to have 6, and it's going to make what's called a double bond. Double, 2 pairs of electrons being shared. You should memorize these. These are the Huggleberg twins. These are pretty quick. Now, oxygen and water make, oxygen and hydrogen make water. This is another one you're supposed to memorize. The oxygen starts out with 6 dots, not 3 pairs though. The oxygen has to make 2 bonds. So coming in on one side and the other, and I'm going to even write the word bent here so you don't forget. It's never drawn in a straight line. It has to be bent. Carbon dioxide, another one you have to memorize. Carbon has 4 electrons, and then an oxygen comes in on one side, and the oxygen comes in on the other, and there's going to be 2 double bonds. Now, this is a line. This is a straight line. This one is bent. You got to memorize this. There's really no reason to worry about it. Just memorize it. HCl. H has a single dot. Chlorine has 7. And there you go. Next one up, potassium chloride. Now, this is going to be tricky because potassium is a metal, and it's going to make a positive 1 ion. The chlorine is going to have 7 valence electrons, but it gets 1 more from the potassium, and it becomes an ionic compound with brackets. Aluminum, where are we? Potassium chloride? Aluminum oxide. Aluminum is a +3, oxygen's a -2, so the formula Al2O3 is what we have to draw. This means we're going to have 2 aluminums. They're both going to be +3. Each aluminum is going to lose 3 electrons, so that means 6 electrons are being transferred. And then we're going to have oxygens. Oxygens have 6 valence electrons, but each oxygen picks up 2 and becomes a -2 ion. Here's another one. This one gets a bracket also. And here's the third one. And what's important is you see this. +3, +3, -2, -2, -2 equals 0. Sums to 0. There's a perfect transfer of electrons. 6 electrons are given off, and 6 electrons are picked up. Magnesium chloride. Magnesium makes a +2. Chlorine makes a -1. Let me move this up for you so you can see. Crisscross, the magnesium is going to be a +2. And we're going to need 2 chlorines. Each chlorine has 7 dots, but it gets 1 electron from the magnesium, and the other chlorine is going to get, I got to squeeze in my dots there. I'm a little too fast. MgCl2. And then calcium sulfide. Calcium is a +2. Sulfur is a -2. I know that because I put my fingers in the box in the periodic table. Calcium gets drawn with no valence electrons and a +2. And I'll put it on the bottom because it doesn't really matter. Sulfur has 6 dots, but it gains 2 electrons from the calcium and goes there. And the last one, methane, which is the other one you probably should memorize. Carbon has got 4 dots. It needs to make 4 bonds, so we're going to bust them open into 4 singles, and we're going to put an H all around. Now, I know this looks like kind of like a X shape, right? But really in 3 dimensions, it's going to have more of a triangular pyramid shape. I'll try to draw it. It's going to look more like this. There's going to be an H to the back, an H to the front, and then another H to the back. It's going to be really a triangular pyramid shape, which is much harder to draw than it is to see when we make the models. Okay? Homework number 2.